So what I'm having here is the basic, the code snippet to declare a node. Okay, so this is to create a structure which is called as node. Okay, and it has two data members. One is or data field, or whatever way you can pronounce, and this is first field which will contain the exact value, and the second field which will contain the next node. Okay, address of the next node. So this is something which creates link between one node and the other node, right? So first of all, understand one thing, that all the linked list, if you want to implement linked list, you have a an initial pointer, an external pointer called as start. Okay, so like we have top for stack, top variable for stack, and for queue we have front and rear. Likewise for linked list we have the start variable. Okay, the start is nothing but an external pointer which points to the first node, because you should have the address of first node, then only you will be able to traverse through the list. Otherwise if you lost the address, then you can't access the list. Okay, so you should have that first node. Okay, so this is basically, I hope it's recording. Yes. Okay, this is basically let's create a start variable, an external variable, an external pointer, actually pointer variable, right? So for that, either I can declare here itself, I can say start, and I put a semicolon here. But you can also, inside your main function, you can use this set of code. Okay, struct node start, because it's a pointer variable. Okay, so start pointer. Okay, in some books it will be called as head. Okay, so head is also correct. You can either call it head or start. Okay, so let me go with start throughout this course. Okay, so after that, you have to allocate memory to the start variable. Okay, you have to allot memory. Okay, because you are just creating, you are just writing the structure, you are not actually allotting memory for it, memory for the structure. You have to do that, right? How do you do that? Okay, so you can do that. So I'll say start equals to, you can allot memory using malloc function. Okay, I told you that, right? Malloc function. Okay, an malloc will take a single argument. Okay, the argument is the size which you want to allot. For example, if you want to allot 2 bytes, I have to put 2 inside here, malloc. Okay, but in this case I want to allocate memory for the struct node, and I don't know the exact size of this struct node data type, right? Because for in case of primitive data types, say I'll have integer will be having 4 bytes. I mean, to store an integer we need at least 4 bytes, right? In case of modern compilers. But here struct node is a user defined data type. I only define the struct node, and I don't know the exact size for this. So to get the size, you have to use the size of operator, right? So this is an operator which will give you the size. So inside size of, what should you pass? You should pass the struct node. Okay, and whatever be the size, and that number of bytes will be allocated. Okay, so it will be calculating the size of our struct node, and it will allot memory. Okay, and the memory will be returned as a void pointer. Okay, I'll explain what is void pointer. Okay, it will be returned as a void pointer, and of course you will be getting the first address. Okay, memory will be allotted, and you will be getting the particular address. A node will be created at your computer. If you do this operation, a node will be created. This is just writing. So node will be created if you use this operation in your computer, in your memory. Okay, and that node's address will be returned by this malloc, and you have to typecast it to struct node pointer, because you are pointing to a struct node. So you have to typecast it like this, because this is a void pointer. So you know what is typecasting, right? Converting to another data type. So this is a void data type. Void means it's nothing. A void, it states. So typecast it to a struct node. Okay, so start will be now having the address of the memory will be allotted. So start will be having the address of the first node. Okay, for only one node the memory will be allotted. Fine. So this set of code is very important, guys, as far as linked list is concerned. So please be familiar with this set of code. Okay, so in our next video we'll actually write some code on linked list. I'll teach you how to create a linked list using C program. Okay, thanks a lot.